Just like we learned the distributive property that takes something that's being multiplied on the outside of a group in parentheses and we multiply it in to each term, we can undo this by factoring out the greatest common factor. And the GCF is going to be something that evenly multiplies into everything in the expression. So in this first one, if we distribute the 6 in, we would get 12x minus 30. But if we're going backwards and undoing that, we're looking for a number that goes into both 12x and negative 30, and we're going to divide each of those terms by that. If we didn't know off the top that we knew it was going to be 6, we can go ahead and divide by a number we can see goes into these, like maybe 2. Take that out to the front, and then we see what is left here after I divide by 2. 12x divided by 2 leaves me 6x. Negative 30 divided by 2 leaves me negative 15. And at this time, now I'm going to check and see, is there anything else I could take out? I can take out a 3. So when I divide 3 out, I'm left with that 2x minus 5 that we knew we were going to get to. And this in the front, this 3 times 2 is just going to become our 6. That's our greatest common factor. So we're going to practice this. With 9x minus 12, I'm looking for a number that goes into both 9x and into negative 12. I can see it's going to be 3. So I'm going to divide 3 out of each of these terms and see what I have left inside here. 9x divided by 3 leaves me 3x. Negative 12 divided by 3 leaves me negative 4. I'm just double checking to make sure, is there anything I could take out of both 3 and 4? No. So we'll keep going. On this one, remember that 18x squared is the same as 18 times x, and negative 27x is the same as negative 27 times x. So I can divide x out of both of these terms, and let's do just that to start. So when I divide out that x, I'm left with 18x here and negative 27 here. We lost this x and this x. Now we're going to look and see if we have a common factor between 18 and 27. I know I could take 9 out of those. If you didn't notice 9, you can always start by just dividing. See if 2 goes in, 3 goes in, 5 goes in, etc. So I'm going to take that 9 out to the front, and I'm left with 2x minus 3. Now that's about as simple as we can get it. So we are done. Looking here, I've got an x squared and an x, but this third term has no x's in it, so I can't take out any x's. I do think I could take out a 5, though. So I'm going to take out 5, dividing it by each term, see what I have left. X squared here, negative 2x here, plus 5 here. And I can't take out anything because x squared has only, a coefficient of 1 and x's, and 5 is only 1 times 5, no x's. So there's nothing I could take out of both of those except 1, which wouldn't really do me any good. So I'm done. Here, I notice I have x's on everything. So I can take out an x from all of these. And now I'm additionally going to look and see what I could take out of 20 and 12 and 28. I always start with 2 if I'm not sure, so let's do that this time. And we're left with 10x squared minus 6x plus 14. Now I notice those are all evens, so I could certainly take out another 2. Should have taken out 4 to start with. And I'm left with... Now, inside this parentheses, we've got an x squared here, no x's over here, and a bunch of prime numbers, so definitely nothing else to do. We could, though, just write this guy as 4x instead of 2 times 2. Now, this might scare you. Don't get scared. We're going to focus in on what we can do. Let's do the coefficients first. That part looks easier. 4, 6, and 12. 2 is going to come out of all of those. And then we'll worry about all those A's and B's. So looking at these now, maybe let's look at A's first. I have 3 A's here, and 5 A's here, and 7 A's here. So if I tried to divide everything by a to the 5th, like I tried to take 5 A's out of all of these terms, I don't actually have 5 A's to take out here. So I need to take out like the smallest amount that's in all of these. So I'm going to take 3 A's out. That's going to be my smallest amount that's in all 3 terms. And let's see what I have left after I do that. All of those A's are gone. Here I took 3 of the A's out, which leaves me 2 A's here. And then 7 A's, taking away 3, I've got 4 A's left. Now, oh my goodness, I just realized a big mistake. Did you guys notice it already? I hope so. This is not a 12. I divided by 2 so long ago, but I forgot to divide my 12 by 2. This should be a 6. All right, continuing on, let's look at our B's now. I've got 4 B's, 2 B's, and 3 B's all being multiplied together. Individually. 4 B's multiplied, 2 B's multiplied, 3 B's multiplied. What can be divided out of all of those? 2 is I have 2 B's in each of those. I don't have 3 B's in all of those, though. So I'm going to stick with just the things I have. And let's divide out that B squared and see what I have left. All of those B's are gone now. And B to the 3rd, divided by B squared, is going to leave me just 1 B. Okay, now, could I do anything else to simplify here? My coefficients can't be simplified, I know, because 3 is prime. And 2 is prime. This term here has only B's, and this term here has only A's. So there's no common variable that I could divide out. So I think we're as simple as we can go, and we're done. Now these are a preview for how we're going to factor quadratics sometimes. And your first instinct might be to distribute this 2x across or the 7 across. Don't do that. We want to look first, we're looking for our greatest common factor, so let's look for that. So we were looking for something that multiplies into each term here. And I want you to be careful. This is actually one term because we have something multiplied with something. That 3x minus 4, we don't know what it is or how much it is, but we know the whole thing is multiplied with 2x. This is one term. And over here I again have one term. So now I'm looking for something I can divide out of each of these. And I can't divide out anything common between 2x and 7. But in both of these terms, they are being multiplied with 3x minus 4. I can divide 3x minus 4 from both of these terms. And then I'm just going to see what do I have left after I do that. So in the first term, I just have 2x. This cancels with this. In the second term, I just have 7. This cancels with this. And here we are. We have taken out our greatest common factor.